In part 4 of section 8, we'll be looking at our second method for solving a linear system. This will not be a geometric or graphical approach like the first method was. This is going to be an algebraic approach. The geometric approach done with the graphing has its limitations. Mainly the precision that we have with graphing could limit, or really the lack of precision that we have, could limit the accuracy that we really have in finding the solution. So the algebraic techniques that we'll be studying in this section are going to be giving us exact answers every single time. So the substitution method will be the first one that we look at, and the substitution method has a 4-step procedure. The first step says solve for one variable. Then it has the substitute step, hence why we call this the substitution method. Then there's something called a back substitute step. We're going to see quite a bit of that. And then there's the check. So the check is pretty self-explanatory. You take whatever you think your solution is and you plug it back in to the original equations. And we did that in example 8.1, where we were checking and verifying if a ordered pair was a solution or not. So let's start with the first step, solving for one variable. So when you're solving for one variable, you have 4 options. You can solve for the x or the y in the first equation, or you could solve for the x or the y in the second equation. Now, you really can't go wrong with any of these choices. You can pick, like I said, any one of the 4, but if you feel like you prefer not to work with fractions, then there is only one choice that is right for you, and that will be the choice of y from the first equation. And the reason why this one is the best choice, in my opinion, is because it has a coefficient of 1. So for example, let's say that we don't choose this variable to solve for. Let's say that we solve for this x. So indulge me for a moment. If we were to do that, we would end up having 3x is equal to 14 minus 4y, and then divide everything by 3, and we're going to get x equals 14/3 minus 4/3 y. And none of those fractions are going to reduce any further, so we're going to have to deal with fractions throughout this process. So if that doesn't sound appealing to you, then I would not suggest choosing either the first x or the second y either, because those are all going to end up creating something that's a fraction involved. So we're going to wipe this out. We're not going to do this. So we're going to take the first equation, equation number 1, 2x plus y equals 1, and we're going to solve it for y. So this is going to read y equals 1 minus 2x. And notice that I'm not concerned with trying to make it in a mx plus b form, because I'm not trying to graph here. We have to be cognizant of what we're trying to accomplish, and here we're trying to accomplish a substitution, which is an algebraic technique, not a graphical technique. So we're going to take the expression 1 minus 2x, and we're going to use that to represent y in the second equation. So let me write down the second equation. 3x plus 4y is equal to 14, and where we have that y, we're going to substitute in directly there. So this is now going to read 3x plus 4 times 1 minus 2x is equal to 14. So that gives us a brand new equation that is a combination of the 2 equations that we started with. And you'll notice that all we have in here is just one type of variable, just x's. So now we'll use all of the wonderful things that we've used in the past, such as distribution. So 3x plus 4 minus 8x equals 14. We will also combine like terms on each side of the expression. So 3x minus 8x, 4 minus 5x is now equal to 14, and then go through the solving process. subtract 4 from both sides, so negative 5x equals 10, and then divide both sides by negative 5 to get that x equals negative 2. So that takes us through step number 2. We did the solve for one variable and the substitution, and that led us to a value that we can assign for x. But we need to also have an assignment for y. So we're going to do the back substitution step now. This is step 3. So the back substitution is going to have me take the assignment we just made, negative 2 being x, and we're going to substitute it back into the original expression that we used for substitution. So now this is going to say y equals 1 minus 2 times negative 2, which will be 1 plus 4, resulting in 5. So this tells us that we have the ordered pair negative 2, comma 5. So what I'd like for you to do is take a look at example 8.2, which was the graphical example that we did, and you should notice that the system that we're working on right now is the exact same system that we worked on in example 8.2, and we were able to get the exact same answer, the ordered pair negative 2, comma 5. And when we did that example, we went through the checking process to verify that negative 2, 5 actually worked. So I don't need to do that for this example, but that is an important part of the solving process, is going back and performing an appropriate check. So the only reason why we're skipping that here is because I've already done it in example 8.2. All we have here is just a algebraic method for getting to that result.